Hey everyone, this is Fred, and welcome back to the Quantum Bits channel. Today's video is a bit special. It is dedicated to a French 8-bit computer from the early 80s. The Thomson MO5 is not very well known outside of France. But a lot of kids who grew up in France actually used Thomson computers at school. Much like in the UK, where children's had BBC Micros in class. For some reasons my school didn't have computers at all. I grew up with an Amstrad CPC at home, as you may know from my previous videos. Therefore, I know close to nothing about this computer. This will be a fun journey. But enough chit-chat. Let's jump into it. The 80s, what a decade for early personal computers. This is the time where France launched an ambitious initiative called Plan Informatique pour tous, or Computer for All Plan. Its goal was simple, yet bold, to introduce computing into every school and prepare an entire generation for the digital age. Thomson, a major French electronics company, was chosen among other tech companies to supply computers for this effort, leading to the popularization of models like the TO7 and later, the MO5. Thousands of Thomson computers were installed in schools across France. Students learned the basics of programming, math, or grammar through these machines. They were connected together into a local network where kids experienced firsthand the promise of the information revolution to come. But the reach of Thomson computers wasn't limited to education alone. Thomson computers made a splash in French media. They were featured on television and promoted by famous personalities. Even Michel Platini, the legendary footballer, was involved in showcasing the MO5 in an effort to boost its appeal to the public beyond the classroom. Thomson's presence was also strong in entertainment programs. One standout example was Microludic, a TV show dedicated to computers and video games. Participants competed in challenges, and winners proudly took home Thomson computers as prizes. Let's take a look at the Thomson 8-bit computers timeline. It all started in 1979 when a small team was gathered with the ambition to create the French answer to the personal computing phenomenon. Initially called T9000, the TO7 was launched in 1982. Powered by a Motorola 6809 processor, 8K of RAM, and 8K of ROM, it featured a chiclet keyboard and a light pen for screen interaction. It was the first computer of the TO series, which stand for French téléordinateur, meaning computer connected to a TV. The number 7 was chosen to symbolize the 7 uses imagined by the designers for this machine: gaming, programming, education, training, family management, small business management, and telematics. Only 2 years later, an upgraded version was released. The TO770 was powered by a 68090 processor, which is a variation of the 6809 with an external clock. It was still running at 1 MHz though. The number 70 corresponds to the sum of available ROM, RAM, and video RAM. The MO5 was also launched in 1984. It's the first computer of the MO series, which was designed purely for home use. They were smaller and more affordable. MO stands for microordinateur, which simply means microcomputer. It was designed for the same uses as the TO7, minus small business management and telematics. This is where the number 5 comes from. Though they used the same processor, MO computers were not compatible with the ones from the TO series. The TO9 was launched in 1985. Still running at 1 MHz, it added 2 new uses: word processing and file management, thanks to 2 dedicated programs included in ROM. In 1986, the TO8 and the MO6 were launched. They were basically improvements over older versions, thus the +1 names. Despite their best efforts, Thomson's machines faced tough competition from the likes of Commodore and Amstrad. In 1987, they took a shot at the 16-bit market with the TO16, an IBM PC-compatible system. But by 1989, it was clear Thomson couldn't keep up with the rapidly evolving market, and they exited the personal computer space for good. Even though they're long gone, Thomson computers left a lasting impact, especially for those who grew up with them in French schools. But this was not my case, and these are computers I barely know. So when I saw online a really nice offer for one MO5, I just could not resist. And by Christmas this year, I treated myself with a lovely gift. The MO5 came into a single package containing several boxes, just like in 1984. This is quite lovely. It says right here, a whole world in a gift. I like that. Let's see what's inside. All right. First things first. Let's take a look at this package. It contains the power supply unit for the machine. This is a pretty basic brick with an on-off switch and a center negative barrel jack. We'll take a detailed look at it later on. Here's the software that was bundled with this lot. It came in the form of either cassette tapes or cartridges. Let's unwrap these cassettes. A soccer game. Never been a great fan of those. Planète Inconnue. Okay, a space exploration game, I suppose. The next one is a Scrabble game. And finally, here the fifth axis. The next one is a French fantasy role-playing game called Motherboard. It was quite famous at the time and came with 2 tapes and a booklet. The next one is a drawing software, Pictor, la palette magique. Okay, there are 2 fuses inside. That's a surprise. Anyways, this software is to be used with a light pen and comes as a cartridge. Nice. The last one is the Flight Simulator Airbus. It also comes with a nice booklet and a cartridge. The lot also contained 2 joysticks. The first one is a classic QuickShot one from Spectre Video. The second one is its mighty red sibling, the QuickShot 2 Turbo. Oh, clicky. Nice. This is a light pen. It famously came bundled with Thompson's computers for screen interaction. These light pens only work with CRTs, and since I don't have one handy, I won't be able to test it, at least right now. This is, well, I don't know what this cable is. It looks like a part of the power supply unit that would have been cut off. If I add the fuses to the puzzle, it kind of screams that I should not use this PSU. Next up is this nice box in really good conditions. It contains the MO5 dataset that we will use to load programs from cassette tapes. Let's take a look inside. Here's the program recorder. Maybe a bit dusty, but otherwise in perfect condition. It's got its own power cord and connects to the computer with this specific connector. So far, so good. Let's take a look at the included documentation. This is the manual. It will be really useful because I know close to nothing about this computer. A small manual for the program recorder. One for the light pen. One for a communication module, which unfortunately was not included in the lot. The guide has seen better days, but hey, it is almost as old as me, so I won't be judging. And here comes the main attraction. This is a later revision, with a mechanical keyboard, much better than the chiclet one. The case needs a good cleaning, but it's in real good shape. It comes with a Paritel video cable, which was standard for French computers at the time. No obvious problems. It looks really good. The keyboard is not bad at all, just The keys are a little smaller than usual. Yeah, it needs a good cleaning, but I'm really pleased with it. Before anything, let's inspect the PSU. It seems that the loose cable I found was somehow cut off from the PSU, and I really don't trust it. I have already removed the screws. Let's crack this power supply open. This, right here, is the same fuse that we found earlier. That's suspicious. And yes, the power cable was removed and another one was soldered instead. That's kinda shady. Anyways, to be sure, let's test the PSU with a multimeter. The power supply unit is hooked up to the mains. Let's turn it on. 1, 2, 3. Okay, light is red. It turned on. So far, so good. Let's measure the output voltage. Minus 25.7 volts. Even with no load, this is way too high. It should be around minus 17. No way I'm going to use this. Let's build a new PSU. DC Moto, Daniel Colom's website, is most certainly the reference when it comes to Thomson's computers. For example, not only it details the characteristics of the MO5 PSU, it also details how to build a new one from commonly available components. All I need is a cheap 15 volts 1 amp switching power supply, a proper barrel jack, and a switch. Since most PSUs are center positive, I'll have to cross lines inside the switch to get the right polarity. We're back on the workbench with all the needed components. A cheap standard DC power supply with adjustable voltage. It can accommodate various barrel jack sizes. It is set to 15 volts. And here's the switch. Now I have to cross wires inside of it. Let's crack it open. I had to fight a bit to open the plastics, but there we go. The mechanism is pretty simple. Let's warm up the soldering iron. Thanks to the magic of a jump cut, here is the result. The wires are crossed and secured with a shrinking tube. Let's put our new contraption to the test. The PSU is delivering a little over 15 volts with no load. Nice! And with the cross-wired switch, it outputs minus 15 volts. Perfect. Here's the final result. I printed out and added a sticker on the PSU with a Thompson logo and a center negative symbol. I secure the connection with a switch with black electrical tape. And finally, I sandpapered just a little bit the connector jack because it wouldn't perfectly fit. It is time to take the MO5 for a first spin. The newly built PSU is connected to the mains and the Peritel connector to my OSSC. Let's flick the switch. It turns on. Great. Keyboard is working fine. Fantastic. After this first try, and now that we know it turns on, let's take a look at this computer and its interfaces. This button right here is a reset switch. Next to it is a trap for cartridges. On the right side are connectors for the program recorder and the light pen. On the back are located the power connector, the edge connector, and the Peritel cord. Let's take a look inside. I flip the case and remove these 4 screws. Now I'm very carefully flipping open the top part of the case. The keyboard is attached to the motherboard with these 2 ribbon connectors. Now I'm very gently disconnecting the ribbon connectors. I really hate doing this. They're so fragile. I feel they can break at any time. The keyboard is now fully detached. The next step is removing the video connector from the motherboard. Then I'm removing these last two screws. Next, I'm removing this piece protecting the edge connector. And we can, at last, slide the motherboard from the bottom case. Now let's take care of the keyboard. First, we have to remove all the screws circled in red. Next, I'm pulling off all the keys one by one. Let's try with the first one. Each key is actually 2 springs. The keys themselves are in good shape, though very dirty and sometimes yellow. Time for a jump cut. And voila! I'm almost done removing the keys. The last step is removing all these little screws. I have now access to the membrane, and oh boy, it is really dirty. I'm using a small SDDrive vacuum cleaner to dust off the membrane and the keyboard. Okay, this is much better. Meanwhile, I took care of the keys and let them soak into warm, soapy water. I did the same with all the other plastic parts. A good warm bath, cleaning product, a toothbrush, and elbow grease. As a final touch, I like to coat all plastic parts in a 303 to protect them and give them a nice shiny look. The keys have been soaking in a soapy water for, I don't know, something like an hour now. So let's dry them one by one with a soft cloth. They look much better. Putting back each key and its outer spring one by one is a bit tedious, but that is that. There we go. Now I'm putting the stabilizers back. And finally, I'm putting one by one the inner springs. A last wipe on the membrane, and it is time to close the keyboard back. Cool, a nice clean and fresh smelling keyboard. Let's take care of the motherboard. First, I'm removing dust with a vacuum cleaner. Next, I'm spraying IPA all over the motherboard. Then I'm using a cleaning wipe and an SDDrive brush. I find this method to be quite effective. I clean this way both sides of the PCB. I'm following my usual cleaning routine, spraying contact cleaner on all connectors. For the edge connector, I'm using a magic sponge. It's a bit abrasive, so you have to be careful, but it works nicely. The PCB is nice and clean. Let's take a closer look at its main components. Starting with the CPU, a Motorola 68A09E, clocked at 1 MHz. Close to the CPU are located 48K of SDRAM. At the heart of this architecture lies this specific gate array. 16K of ROM are storing both the OS and the basic interpreter. Finally, this PIA handles peripherals. The PCB is back into its case. I replugged the video connector and added a cable tie to replace the grommet I had to remove. Everything is put back. The MO5 is now clean and shiny and ready for a second test. Let's see if it is still running. I'm turning the power on. Crossing fingers. Yep, it still works. Great. Cool. Now let's take care of the program recorder. Like the rest of the package, it is in really good shape, though very dusty. The program recorder is connected to the mains. Let's see. Forward is working. Stop and backward too. Play also works. And the counter is working too. Great. Let's remove the screws circled in red. It looks pretty good. The belt is in good conditions too. No need to replace it. Good news. Let's remove the transformer, the PCB, and the mechanical parts from the case. I guess it is time for a little montage. And here we are. I'm going to later clean the case. Let's first take care of the tape recorder. First, I'm removing all the dust with compressed air. Next, I'm cleaning the mechanical parts and the heads with IPA and chamois swabs. Everything looks good. Great. Just like the computer case, the program recorder is taking a warm, bubbly bath. I'm back on the bench. I'm taking care of the PCB with a wipe soaked in IPA and a soft brush. Ew, that's disgusting. Both the computer and the program recorder are now back in shape. I'm turning the computer on. Let's try to load a game from tape. Yeah, that's going to take a while. Le chargement est en cours. It means loading is in progress. That's a start. The first stage of the game is loaded. I'm going to ignore the instructions and hit 3 to load the second stage. The game is loaded and it's all working good. I used to play to the 5th axis on my Amstrad, but I never could finish it. Gosh, I'm still bad at this game. The lot came with 2 cartridges. Let's try them, starting with Pictor. Pictor is a drawing program for kids. It mostly uses the light pen, so I'm not going to be able to do much. But it's running, so I'm going to call it a win. The second cartridge is simply called Airbus. It is a flight simulator from 1984. I'm going to select Takeoff Practice, and Easy Mode, I guess. Who knew I could fly an Airbus with an MO5? The SDDrive is a fantastic little device designed and sold by Daniel Colomb. It's a modern disk controller / floppy disk drive combo for Thomson TO and MO 8-bits computers. It plugs into a minibus bridge that extends the edge connector of the computer. It comes with its own menu software that is loaded at boot time and allows the selection of a disk image. The disk images and the menu software are stored on an SD card. So I headed to the System CFG forum, contacted Daniel, ordered a SD drive and a minibus, as well as a pre-configured SD card. Barely half an hour later, Daniel answered back. How nice. And about a week later, I received Daniel's package. Let's open it. This is the SD drive itself. Really neat and well built. And here's the minibus. The SD drive is plugged into the minibus. I'm plugging the minibus into the extension port. Easy peasy. I'm turning the power on. The selection menu appears right away. Cool. Such a nice device has to be protected and needs a case. So I designed a very simple 3D model. It's my first 3D design, so please don't be too harsh. At the time of recording this video, something like 5 to 6 months ago, I didn't have a 3D printer, so I sent the design to a well-known service provider. A few weeks later, here's the package I received. Please note that there is no sponsorship here. I must say it came out very, very nicely. Cool. My design is very, very simple. Just a case, a top that snaps in, and proper holes for the SD card and the LEDs. It fits beautifully. I am really happy with it. Oh, a big thank you to Daniel, who nicely mentioned the case in his website. This is the final result. I just printed out 2 stickers in the fashion of Thompson extensions. It's not perfect, but I'm happy with it. I'm back to Daniel's website. There, you will find a whole collection of program images in the proper SD format. Just select a game and download the image. It's super convenient and easy. I'm back on the workbench with the SD card. I'm plugging the card into my Linux box. All you have to do is to drop the .sd files into the card. Just remember to add the SDDrive.cell file that will provide the selection menu at boot time. That is so easy. At power on, the selection menu appears. It lists the images that I gathered on Daniel's website. You can navigate the menu with the up and down keys. I'm selecting Arkanoid and pressing Enter. It loads almost right away. How cool is that? Well, it's been a really fun journey. Until now, I had never touched a MO5 in my life. As a Frenchman, I'm kind of ashamed for that. Indeed, what a lovely little machine. And I must say, I'm particularly impressed by the whole Thompson 8-bit community. I'm sure there is still so much to learn. The story of Thompson in itself is quite fascinating. In the meantime, let's conclude this video with a few games. Thank you for watching this video. If you like it, you can give it a thumbs up or even subscribe. Feel free to add any comments. See you very soon on the next video.